Hello guys, in this video we will be studying about glycogen storage diseases, but first I would like to give you an overview of glycogenesis and glycogenolysis. So what happens in glycogenesis? Glycogenesis means formation of glycogen from glucose, and this process is taking place in liver and skeletal muscles. So first this glucose has to be activated. This process is known as activation, and UDP glucose will be formed. What will happen? This UDP glucose in presence of glycogen synthase will go to protein glycogenin, attach the glucose to tyrosine component of this protein, and it will be removed. I'll repeat again. UDP glucose will go and it will attach glucose to the tyrosine component of protein glycogenin, and UDP will be removed. This process will be repeated several times and we'll get a linear chain of glucose. This enzyme glycogen synthase is the rate limiting enzyme for glycogenesis. Now, as we know, glycogen is the branched polymer of glucose. So now in presence of branching enzyme, this linear chain will be branched and we'll get glycogen. Let's study glycogenolysis now. Glycogenolysis is breakdown of glycogen into glucose. So first, glycogen in presence of glycogen phosphorylase will be converted to limit dextrin. So let me explain how this glycogen phosphorylase, which is the rate limiting enzyme of glycogenolysis, working. So this glycogen phosphorylase, it will start removing glucose from the side of glycogen. Imagine this is glycogen. For example, it removed 99th, the 98th, 97th, 96th. But it will stop at a place where only 4 glucose are left from the branching site. And this left part is known as limit dextrin. Now the glycogen phosphorylase cannot come and remove glucose from glycogen. So what is this glycogen phosphorylase doing? It is basically removing glucose, 1,1-glucose in the form of glucose 1-phosphate, but it will stop at a place where only 4 glucose are left from the branching site, and this part is known as limit dextrin. Now, in order for our glycogen phosphorylase to act again on glycogen, we have to debranch it and make a linear chain. Hence, limit dextrin in presence of debranching enzyme will form linear chain. Now, again glycogen phosphorylase will come and start removing 1,1-glucose in the form of glucose 1-phosphate. Now, this glucose 1-phosphate in presence of mutase will form glucose 6-phosphate. Now, this glucose 6-phosphate in presence of glucose 6-phosphatase will be forming glucose. As we know, phosphatase means removal of phosphate. So, 1-phosphate is removed from this glucose 6-phosphate. Hence, glucose is formed. Now, let's study the diseases. So type 1 is von Gierke's disease, which is caused by deficiency of glucose 6-phosphatase, which was required to convert glucose 6-phosphate into glucose. Type 2 is Pompey's disease. Let me tell you this. While going glycogenolysis, some of the glycogen will enter lysosome and it will undergo certain reactions in presence of acid maltase, which is also known as lysosomal glucosidase. So deficiency of acid maltase or lysosomal glucosidase will cause Pompey's disease, which is type 2. Type 3 is Cory's disease, which is caused by deficiency of debranching enzyme, which was required to make linear chain from limit dextrin. Type 4 is Anderson's disease, which is caused by deficiency of branching enzyme. Type 5 is Meckel's disease, when there is deficiency of glycogen phosphorylase in muscle. Type 6 is Her's disease, when there is deficiency of glycogen phosphorylase in liver. Now let me tell you a mnemonic to remember all these types of glycogen storage diseases. So let's start with 3 and 4. A, B, C, D. C is the third alphabet. C is the third alphabet and C for Cory. Cory's disease is caused by deficiency of debranching enzyme. A for Anderson, and it is caused due to deficiency of branching enzyme. I hope you'll remember it. So C is the third alphabet, and C for Cori, caused due to deficiency of debranching enzyme. A for Anderson, which is the fourth type glycogen storage disease, and it is caused due to deficiency of branching enzyme. Now, how will we remember McArd's and Hirsch disease? Because both are, caused due to deficiency of glycogen phosphorylase. So, M for McArd's disease and M for muscle. So, if there is deficiency of glycogen phosphorylase in muscle, it will be McArd's disease, which is type 5. Type 6 is Hirsch, which is due to deficiency of glycogen phosphorylase in liver. Liver can also be known as hepatic. So H for hepatic, H for Hirsch. I hope